Now we're going to move on to the example portion at the bottom of your organizer that you were given. Let's do an example of each single identity that you should know how to do. We're going to be starting with Pythagorean identity number 1. These we have already done in task 84 when I did an example with you. But I'm going to go ahead and do it again just so you can compare how it's different from the other two identities. So for this one, because I'm given sine and they're asking me to find cosine, so I'm given sine, they're asking me to find cosine, I'll be using this trig identity. Alright, next thing is what I'm going to do is plug in or substitute 4 over 5 into my sine equation because that's what they gave me. And remember, the goal is to find what cosine theta is. Alright, from here, the squared is going to go to the top and to the bottom. So 4 squared will give me 16, 5 squared will give me 25. Great. So again, I remind myself the goal is to find cosine theta. So what I'm going to do is I got to get this cosine squared theta by itself. So I have to subtract 16 over 25 from both sides. When I subtract 16 over 25, I'm going to rewrite this 1 right here into 1 over 1. Because in order to subtract a fraction, I gotta make sure I have common denominators. So what I'm going to do is I'm going to multiply this 1 over 1 by this denominator, which is 25 over 25. That's going to give me this next step. Alright, now that the denominators are the same, I'm going to go ahead and subtract my numerators. So 25 minus 16 will give me positive 9 on top, and we're going to keep the denominator the same. The last step is I want to get rid of this little squared right here because remember my goal is what is cosine theta. So I have cosine squared theta equals 9 over 25. I want to know cosine theta. So to get rid of the squared, I'm going to square root. Usually we're square rooting both sides, and when I do that, the square disappears. So cosine theta equals the square root of 9 over 25. Now my last step is I must simplify. The square root of 9 will become 3. The square root of 25 will become 5. That is my final answer. So cosine theta is equal to 3 over 5. This is the answer. We are done. We have found cosine theta. Okay. Now let's move on to this next example. So this one right here, because this is not a fraction, this will be a much more easier calculation. So they're giving me tangent and they're asking me to find secant. And if I look back to my identities, the one that has both tangent and secant in the equation is my second Pythagorean identity. So I'm going to be using this one. When you will be given problems, you have to make the choice whether to use Pythagorean identity 1, 2, or 3. In this case, I'm already telling you which to use just to better organize what we're doing here. Alright, so in this problem, it's telling me that tangent is equal to 2. So what I'm going to do is go ahead and substitute the 2 into a tangent there. It's going to show up in red. Alright, so 2 squared is going to give me 4 plus 1. That's 5. To solve for secant squared, to get rid of the squared, we square root both sides. Square rooting both sides gets rid of the square. That's why secant is now by itself. Alright, so square root of 5 does not simplify. Therefore, my solution is that secant theta is just simply the square root of 5. That is my answer here. We have found secant theta. We have found our goal. I did forget to mention here that because all these problems that I'll be giving you following this task, the theta is between 0 and 90 degrees. That means we're only looking at the positive square roots. So I want to again remind you guys, usually when we square root both sides of the equation, we usually have to include a plus or minus. But because I'm restricting this between 0 and 90 degrees on the unit circle, that means we're only looking for positive roots. So we do not have to worry about plus minus in these examples. So I just want to put that reminder here that because the theta is in the first quadrant, which is always positive, we again don't have to put plus minus here. Usually we have been doing that. Alright, now let's move on to Pythagorean identity number 3 example. Again, this is going to be positive. I don't have to worry about plus minus when I square root both sides. But they're giving me cosecant of theta equals 5 over 3. What is cotangent? So I have to use the Pythagorean identity that has both cosecant and cotangent. So that's this one right here. Great. Cosecant is 5 over 3. So in this case, 5 over 3 is going to get plugged in right here. And that's going to show up in red. Then we're going to solve. So again, because this is a fraction, there's going to be a little more steps involved. This squared right here is going to apply to the 5 and to the 3. 5 squared is 25. 3 squared will become 9. In order to solve for cotangent theta, which is our goal right here, got to get rid of this plus 1. So what I'm going to do next is subtract 1 from both sides. When I subtract 1 from both sides, I want to make sure that I put this 1 over 1 because I want to have a common denominator. And that's why right at this step I multiplied 9 top and bottom from this 1 over 1 so that I can go ahead and combine these fractions because this 9 is down here. Alright, so this right here is going to become 9 over 9. Now that the denominators are the same, 25 minus 9 is going to give me 16 over 9. Now, in order to solve for cotangent, which is what we're looking for, we must square root both sides to get rid of the squared. Square root gets rid of that squared. I'm going to go ahead and do that. And again, the square root is going to be positive because we're only looking at the first quadrant. Alright, so now the square root of 16 over 9. Square root of 16 will become 4. The square root of 9 will become 3. So that simplifies into 4 over 3. We have finally found cotangent. That was the goal of the question. That would be the answer that you would circle, and basically you're done. Again, these are 3 examples of how to do each identity. When I'm giving you a problem, you have to decide which identity to use to solve your problem, depending on what the question is asking you. If you look for further help and need some further examples, please come by to office hours.